Hello everyone, thanks for coming to this session. My name is Mikkel. I'm one of the founders of SYNQ, a data observability platform. And today I'll talk about how you can use data observability alongside MCPs and dbt to build better tests and solve production issues faster. So scaling data quality is really hard. If you watched dbt's keynote yesterday, they alone have more than 1,500 dbt models and more than 2,000 tests. And some companies have 10 times that. That means when something goes wrong, it's really hard to find out what's the potential root cause and what's the potential impact. When I think about data quality, I like to think about data quality maturity in 3 different stages. At the basic level, you have some tests in place and you react to those when something goes wrong. And I think, let's face it, this is where most of us are at today. Strategic testing is when you have a testing philosophy in place, you prioritize issues intentionally, and you have incident management processes for important issues. And the last step here is automation, which is where I'm starting to see the best teams move, where they intentionally start automating key parts of their data quality workflows. Data observability tooling has a lot of things that can help you, no matter where you're at in this data quality journey. At the basic level, you can add anomaly monitors on top of your dbt tests that can help you catch unknown unknowns that would otherwise be hard to detect. At the more strategic level, you can start anchoring your testing in data products and pipelines instead of in models and tables, and manage incidents through proper incident management. And finally, you can start using this toolbox of available metadata from data observability to automate key parts of this workflow. Let's try to put this into practice. So what we have over the next 20 minutes is a New York City taxi data set that we load into BigQuery. We transform it through dbt, and we then have a layer of observability monitored through SYNQ. We'll be using MCPs for this, that you probably all heard about at this point. And broadly speaking, there are 2 different ways to interact with MCPs. One is through IDEs like VS Code, Cursor, or Claude Code. And the other way is through chat apps like OpenAI or Claude Desktop. For the purpose of the demo for the next 20 minutes, we'll be using Claude Desktop, but in practice, a lot of the workflows that I'll be showing you, you probably want to do in your IDE in real life. So next 20 minutes, what we'll be doing is we'll take a data product around this New York City taxi data around trips. We'll deploy strategic testing to that, and then we'll deal with this production issue that you can see happened a few weeks ago. So let's start out asking Claude Desktop around what test would you recommend for this data product. You can see now it goes away and it starts thinking, and it then connects to what's called tools. Here it looks at the schema. It also looks at previous checks and tests in place. Then it comes up with relevant not null tests on specific columns. It looks at accepted values. It sees that there are existing relationship tests and checks in place. And it comes up here with certain ratios around that a percentage shouldn't be above 100 or below 0. This is all pretty reasonable, I would say, and this is what I would call basic testing that we just did here. And as you can see, that was fairly simple. It's really important with these MCPs to understand how they work under the hood and what actually happened for this to take place. So what we did is we put into Claude Desktop, what test would you recommend for this data product? Claude Desktop then uses the SYNQ MCP to connect to a set of tools. And you can think about these tools as what's available for the MCP to look at. In this case, we look at the SYNQ MCP, which has a lot of quality-related metadata from listing recent code commits, upstream dependencies, and so forth. But it actually only looked at schema and list checks in this case. There are many other MCPs. dbt has one that's really good for data discovery. Omni has one that's great for BI use cases. And no matter what MCP you use, you should go in here and understand what are actually the tools available for this MCP. We do want to move, though, from basic testing to strategic testing. And in order to do that, I find it really helpful to think about your data stack in terms of data products instead of tables and models. And what I mean by a data product, in this case, a data product is actually just an important dbt model around trip distance data. But we also need to consider everything upstream of this dbt model or this data product in order to do data product-centric testing. On top of that, we also need to think about who's the owner, who needs to be notified, and how important is this data product relative to other data assets in our stack. With that in mind, I like to think about testing in terms of layers. So when you think about how you deploy tests, I think about it from how data moves through your pipeline, going from operational systems into sources, from sources through transformations in the data warehouse, and finally into data models and marts that are ready to use. And the hard thing here is, depending on where you are at this stage, you want to have very different tests. So I always recommend that you test very heavily at the source level to catch issues as fast as possible upstream. That includes things like uniqueness, completeness, freshness, and volume checks on data. The second thing, when you look at the staging or aggregate layer, the key recommendation I often have is just to test less. So I see many teams replicate pretty much all the tests that they have upstream on models all the way through their lineage, and I don't recommend that. So instead, we have a philosophy that if a column is a pass-through, so if you do no transformations and no joins, you don't need to replicate the test that already exists upstream. And lastly, at the marts or data product layer, you want to check and test for specific business logic. To make matters worse, it's often different people who got expertise about different steps of this journey. So data engineers might know most about how data lands in the data warehouse. Analytics engineers know most about how data is transformed through the pipelines. And data analysts typically has most context around how data is used. The best teams are starting to capture this testing philosophy into a document. And you might have seen this referred to as context engineering. And this is essentially where the human meets the AI. So you can see what we've done here. We've actually taken all the things I specified before around our source level testing, transformation testing, data product testing, and even specific guidelines for the specific data product, and we've captured that into a document. I recommend that you save this document as a context.yaml file, keep it version controlled, and then you have a way for everybody to actually keep track of what is the testing philosophy. And this is also a major advantage if you onboard new joiners and you want to bring out a cohesive testing strategy. So let's go back to the example we had just a few minutes ago. We now ask again, with this new testing strategy, what test would you recommend? You can see the first thing it actually does now, it considers upstream dependencies. So it no longer just looks at the specific table itself. And just to give you a sense of what it then does for each upstream dependency, it passes in a model name and then it responds with a set of output around relevant information about that specific upstream table. It also looks at the code, which is very important for understanding how data and columns are transformed and to see if they are just passed through. So with this in mind, you can actually see it now recaps the strategy we provided. So test heavily upstream, no pass-through testing. We've even specified that it should add a specific tag for data products. You can see we get relevant not null tests. Interestingly, here at the transformation step, you can actually see it removes specific tests and it says why it does it, which is very helpful. The data product has the relevant tag that we required. And there's a lot of other tests and checks that you want to evaluate one by one. And you can see here a summary. We've actually now added more tests upstream, but we've removed tests at the transformation and aggregate layer and also added more tests at the data product. So I'd say we've now gone from having a very basically tested data product to now a very strategically tested one. As you can see, the context engineering is really, really important to get right, because that's essentially the blueprint that the LLM uses to do the testing. What we just did, I would classify as just right in terms of the specificity. So we say focus testing on sources, don't test pass-through. For data products, make sure you have a anomaly monitor tag in place. A counterexample could be on the left. You can see we've very, very specifically specified down to individual tables, almost what should have been captured in code instead. That's too specific, and that's not going to give you the results that you want. On the right-hand side, on the other hand, we've also been too vague, and we've left way too much room for the LLM to interpret and make stuff up. So you want to think about what's the right level of specificity as you develop this context engineering. The good thing here is you don't necessarily have to come up with everything from scratch. So if you look out there, there's a bunch of vendors and a bunch of other resources that have very good defaults that you can implement and take into account. So we've written a guide around data product testing. DBT has great best practices around how to structure your DBT projects. Atlan, the data catalog, has very good resources around cataloging and metadata tagging. So go out there and see what already exists. So just recapping what we learned here around strategic testing. The first thing is think about testing in layers, going from data landing into the sources, being transformed, and then finally being used in marts. And the second thing is establish these centrally managed guidelines where your team can contribute, and you often want to capture that in a context.yaml file that's managed in your DBT project. And the third piece here, and that's really important, so you saw a lot of tests being suggested by the LLM just before, and one mistake I've seen teams do is just blindly accept all of those. What you want to do in practice is you want to use your domain understanding and actually evaluate each test that's being suggested and say if it makes sense in your use case. The second topic for today is how do we then deal with a production issue? So you can see here we got an alert in Slack saying that the revenue for a specific vendor has dropped to 0 for the last few days. If you work in a data team, you're probably very familiar with that this starts a whole sequence of maybe not so fun tasks, from looking at error logs to looking at recent code commits, database changes, upstream dependencies, maybe even searching in Slack if anyone did something that caused this. Again, turning to the LLM, here we've provided a set of guidelines for how it should think about debugging data issues by sourcing that from different teams and understanding how they run this process. So you can see it starts by outlining the steps that we've actually suggested here based on how we've seen other teams do it, looking at recent code commits, take into account schema changes, upstream issues, and so on. First, it rules out that there's been no recent code changes to the table the last 14 days. It also rules out that there's been database schema changes. Then it looks into how data flows and if there's been any issues on the upstream table. It then looks into how this specific revenue column that had an issue came to be and all the transformation steps that lies in it. Then it goes on and looks for similar vendor issues to isolate, is this an isolated issue or have other groupings seen similar types of issues? It then looks at historical patterns. Is this a one-off event or has this actually recurred several times? And very important here, you can see it mentions that Stephen Murphy has been investigating a similar issue, and Stephen is one of my colleagues. And finally, it does this deep upstream to source analysis looking at all the dependencies upstream and runs the same analysis. It then gets to the final root cause where it rules out a lot of potential issues, and it points to that it's actually caused by the total amount column in the most upstream table. So I don't know about you, but this would have saved me a lot of time back when I worked in a data team. The second thing here, so if we imagine I'm going on holiday next week, I want to hand over a state of the union of my data issues to one of my colleagues. So I ask here, write a handover report including things like issue, duration, severity, owner, status, and so forth. And you can see again, it always lists what tools it's using from the MCP, so you can get that full visibility. It then lists all the different issues. You can see if there's a related incident that's live. It does that across single anomaly monitors, SQL tests, DBT tests, and so forth. And one key thing I've seen as our customers have adopted this in their weekly workflow is if they run this, they get something a bit different each week. What you really want is you want the same thing every single week. So you can actually engineer the LLM to give you a prompt that runs specific tools each week. That makes sure that you get the exact same output every time you run this. So this is already a lot of powerful tooling, from getting to the root cause of an issue, handing that over to a colleague, and then creating a script that we can run every Friday that generates the exact same thing. So if we look at here what we learned in terms of handling production issues, the first one is it only really works when you have the right testing in place. So you really need to think about this data product level testing, making sure that you've set in place the right test and checks and anomaly monitors to catch issues in the first place. The second one is you should really take and collate across your data team what usually happens when you have an issue, and then put them into guidelines that you want the LLM to work through. And the last part, which is really, really important, is you should start treating important issues as incidents. That means you should note down who's working on it. You should add comments and updates in there, because then the LLM and the MCP can actually read from that incident, and it can bring that relevant information into the issue resolution workflow. So I'd say we now have a reliable, strategic, tested data product, and you should see a few things happen as a consequence of this. The first one is that time to detection should go down significantly because you have more relevant tests in place to catch issues. The second one is that the time spent to resolve issues should also drop significantly. As you just saw, a lot of these things that you would do as a human can be automated by the AI. And the last thing, which is often overlooked, if you do this, you start getting a system that's more transparent, has less irrelevant tests, and makes it much easier to hand over to colleagues or other people in the company. I'd say one thing here to end off with, hopefully you're all thinking about somehow what AI workflows you can be using. I don't know about you, but I see very often people start on the very right. So they think about how do we take our BI tool and how do we make that accessible through a chat interface for everybody to use. I think that's a great use case, but it's also very risky if you think about it. So that's often used by people outside the data team with very little context around what goes wrong or how the data works under the hood. And if something comes back and it doesn't look like they expected, they might lose trust in the AI system, or they might even lose trust in the data team. The workflows we looked at now around testing and debugging data issues, you're still in the driver's seat as the data person. So I consider those much less risky and oftentimes a better place to start. That saying, there's a lot of middle ground as well, like BI for analysts might be a place you can start as well. But I think thinking about AI and thinking about where and what human is in the loop is really important. So I just showed you today a few of the use cases that's possible, but you can really think about MCPs as opening up this world of connecting tools like Cursor, ChatGPT, Claude Desktop and so on, to many other tools, and then bringing in that context. So we've already seen teams use that for metadata discovery with the dbt MCP. We've seen them use our MCP for raising PRs directly in production, and much, much more. So I left the box here for you to come by later and discuss your use case. The last thing I want to end up with is we have a guide that you can download with a lot of steps and best practices no matter where you are in your data quality journey. So you can download that on sync.io/guide. I also have a few copies up here. So if you want to come up afterwards, I'm around for the next 10 minutes for any questions that you might have. That's all I had for you today, so thanks for coming by.